My name is Alvaro Augusto Salles, and I am an electrical engineer, and I am a professor at the university in south of Brazil, in Porto Alegre, and that's the Federal University of Rio Grande do Sul. The name of the state is Rio Grande do Sul, and Porto Alegre is the capital of Rio Grande do Sul. And there I work in the electrical engineering department. And since several years we have been studying the subjects related to wireless communications, such as cell phone systems, the towers, the base stations, the mobile phone. And what we do in the electrical engineering department, we do simulations of those emissions, say for the cell towers, the base stations. You are in the far field. People are in the far field. We can simulate that, and we compare the results with the standards, the recommendations. And we do this also for the mobile phone. We do the simulations when the mobile phone is approaching to the head, and when you speak it with it very close to your head. So therefore we simulate the brain and the other tissues in the head of adults and of children, okay? And out of these simulations, the end of that are the SAR, specific absorption ratio, in every part of the head. And after that, you are able to compare the SAR obtained with the international recommendations, such as the recommendation in this country, 1.6 watts per kilogram, and the recommendation, the international recommendation from a commission we call ICNIRP, which is 2 watts per kilogram. So we do those simulations, we compare with the regulations, and also we try to improve the performance of the cell phones. We design new antennas to shape the beam to the opposite side of the head. You don't want electromagnetic energy being absorbed in the user's head. Therefore, new antennas, directional antennas we call, the beam is shaped away from the head, and therefore what you have as improvement with these new antennas, you have more energy going to the nearest base station, so you improve the quality of the communication. You save battery because the cell phone will operate at lower levels. You save the battery, you have more time to use that battery. You reduce the energy consumption of the battery, and last but not least, you reduce the risk for the users when the antenna is directing the energy opposite to the user's head. So that's some of the work we do there. This is not a new solution. They know this solution, and many manufacturers, they have patents for these we call planar antennas. And these use technologies very well known, such as microstrip and other technologies. They are established, and they have the patents, but when you ask them why they do not use this new type of antennas, they do not have a reasonable answer to this question. And some people say that they do not use these antennas because they would have to explain why they are not using the previous antennas.
Mm-hmm. But they could make more money by saying, "Oh, look, we just developed a newer, better, safer model."
Yeah, this is, I do agree with you, but they will have to say that. I have already said to them in private conversation and also in conferences where they were there, and even in some hearings in Brazilian Chamber of Deputies. I said this to them, but they didn't do that until now.
Do you have manufacturers in your country, Brazilian cell phone manufacturers?
No, all are the international companies such as Nokia, Motorola, Samsung, and others. Mm-hmm. But they have, I know they have the patents. I know, yeah, because I tried to apply for a patent for these antennas, and the answer we had is that these antennas have been already patented, and they gave the name of the several types of antenna. But this, you understand, is like a light from a car. The light from a car is directed like a beam. Okay, the usual antenna normally being used in cell phones are non-directional antennas. So they are like, if it were this, emitting symmetrically around it. So when these antennas in the cell phone, you don't see it, but they are there. When these antennas are approaching to your head, the emitted pattern changes. Instead of being a circle around the antenna, it will be more concentrated in the head. Why? Because the head has got some electrical parameters higher than the air, such as the dielectric constant. It's around 70 to 80 times higher than the air. So this parameter means that the energy, electromagnetic energy, is much more concentrated in those tissues. So instead of having a circular beam, circular pattern around those antennas, it will be an ellipsis, concentrating more energy in your brain. When you make the simulations, if these cell phones are around 2 centimeters from your head, about 50% of the energy is dissipated in your head. In the normal position of operation, when the cell phone is held on your head, more than 70% of the energy is being dissipated in your brain. So it's not only the case of reduce the risk for the person, it's also a subject of energy consumption. You are wasting energy for a purpose you do not want. Obviously, the worst part of the question is the risk, but Even if you take off the risk, you are doing a bad engineering solution. Therefore, if you use a directional antenna shaping the beam opposite to the head, you are saving energy, you are improving the quality of the communication, you are reducing the battery drain, and you are reducing the risk. So it's obvious, it's a reasonable solution. So your question, why do they do not use this sort of antennas? Everybody puts this question. I don't know. They should answer this question. The industry.
So tell us what you've done, what the people in Porto Alegre have done.
Okay, so that's the work we do in the university, but also we are helping we were helping the Chamber of Deputies in Brasilia to put a national law trying to reduce the exposure of the people. And that's related to base stations and to mobile phones. Because I'm not talking only on cell phones. Any mobile phone, any wireless devices, you can have similar situations. So for the Porto Alegre city specifically, in Congress, we didn't succeed until now. We will succeed, we will. But we do not have until now a good regulation. But in the city of Porto Alegre, we have two good solutions. One for the base stations and the other fixed transmitters such as TV, AM, FM, and so on. And we have other law. We have two. We passed two laws. The other is for the mobile phones. What are the main achievements with that? First, we reduced in the law. We reduced the exposure for the people. Instead of following the national law, which is based in ICNIRP limits, we are following part of the precautionary principle when we adopted levels similar to those used in Switzerland. So instead of being, say, 40 volts per meter in 850 megahertz, it's down to 4. And instead of being 60 volts per meter in 1.9 gigahertz, we go down to 6, from 60 to 6 in electric field. Therefore, the density of power goes down 100 times. If you reduce the electric field 10 times, the density of power will be reduced by 100 times. So that reduces the risk. I am not able to say if this is safe for the health, but the risk is being reduced substantially.
The quality of transmission?
Oh yes, that's a very important point, because when this law has passed, what the industry and the telecommunication operator said, you will not be able to talk, the system will go down. But we have made already the estimations, and we knew that it would work. And we knew because it's working in Switzerland. So it was not difficult. And so they had to follow these limits, and the system operates very well, no problem to that. And why? It's very easy also, because the technology is there. The cell phones and the base station receivers are very sensitive. Their sensitivity is around, I will give you a figure, it's around minus 100 dBm, minus 110 dBm, minus 120. What's the meaning of that? Is that you are able to receive a very low signal. Why do they not like to operate with lower limits? It's because if they operate with lower limits, the quality of the communication will be okay. But if they have higher limits, of course they can go further away. Sometimes if you are behind a building, you can lose your communication. So that's a question of having more users. So what you have to choose, or to reduce the power to reduce the risk, or you do not reduce the power. You have some of the communications will fall down before, if you are working with lower power. You have to accept that. But at the higher levels, you have have you already had an experience to go into an elevator, a metallic elevator? Sometimes you have a signal in your cell phone. So in principle, you should not have, because a metallic elevator is a kind of what we call Faraday cage. And then you should not have this. Why do sometimes you have the signal inside an elevator? It's because it has got a very good sensitivity. And the figures are those I mentioned to you, minus 100 dBm, minus 110. And the people from the industry, they know that very well, that they have good sensitivity. But the operators, they do not like that. If they have competition, if they have a higher signal, their clients will not change it to the other operator. If the signal goes down, they might have better signal in the other operator. So it's a kind of management. This is a problem that lots of people in the world have been suffering. You know this, and you have a history in this country, for the tobacco and also for the telecommunications industry.
The problem of funding.
Yes, funding and receiving receiving some pressure from the industry. Several kinds of pressure. In my university, it's a public university. I am not. They are not able to fire me due to politics. So I'm not afraid to say, and that's the truth.
But they didn't like it.
Who didn't like it?
The industry that funded you.
No, I had, we collaborate a lot with what we call, I don't know if you have a similar power here. We have we call four powers. Is the executive, the government, the legislative, as you have here, and the justice. That's up to 25 years ago, we had only these three powers: executive, legislative, and the justice. And now we have the four power. Some countries have this, we call Ministério Público. So what the Ministério Público does? It has the purpose and the responsibilities of the Ministério Público is just to look after problems that can harm the population. For example, this subject. And we have been collaborating with them. And eventually, the operator who was supporting a research in my department, eventually they had a trial in the court, and I was asked by the Ministério Público to testify if that base station located where it was could harm the population. And then I said, we have already results in other countries, epidemiological results showing that you can have problems such as cancer in areas close to the base station. So, and I had the papers. I showed the papers. I was not telling even my research, because we are not medical doctors. We just estimate the fields, we measure the fields, we estimate the fields, we measure the fields, and we do the we are able to calculate for example, the electric field in any place of interest. And therefore, we can compare those results with the regulations. And then we say, this here, you are complaining with the regulation used in the States. In this place, you are complaining with the regulation used in Switzerland. And so, the week before, I testified that the project was just they just took off the money from the project. To my point of view, with the present technology, having the good sensitivity, both transceivers have the mobile and the fixed one in the tower. Having this quality, I believe that the best would be if the base stations were away from the more density populated areas where you live or where you work, such as, for example, I don't know here, but in Porto Alegre, the TV towers and the radio towers are in a mountain a few kilometers away from the more dense areas. So now I think the same could be done for the mobile communications. Put base stations at least 1 or 2 kilometers away from the more dense areas. And this applies for any other wireless technology. Away, don't use it in your house. Don't use wireless in your house. They have a project in Brazil, and perhaps you have in this country as well, 1 laptop per child. It's a big project, and it is to use laptop in the school for child, and then we made some measurements. If you have one laptop in a classroom with the base and one laptop, the radiated energy is in one level. If you start to add, as they will have in the classroom, 10, 20, 30 laptops, all wireless connected to a small base station, then the level of energy will start to increase. And the children, they will stay in this class for 3-4 hours. And nobody in the world is able to tell you now that that's safe in a responsible way. You will find several people telling you that no problem with that. You will find, but responsible and serious, nobody can tell. So you are talking about a lab study with those children, as guinea pigs, they say. So it's so I'm saying that any wireless technology should be avoided, should be restricted. Why not using cables on the desk? Then the children will come with the laptop and just plug in the cable. Why radiate all the room during several hours? We know that children are more sensitive than adults. So if there is a harm, they will be the first to suffer with that. Coming back to the cell phones in this country and every country, do you know how do they do the compliance tests with the cell phones? They use a shell with the liquid in it, and so they measure the SAR and they say it's okay, it's safe. The cell phone would go to the market, and an adult can buy it and a child can buy it. Do you know this measurement is based on adults trying to model the head of an adult, trying to model. It's not modeling. Why not? Because that's an homogeneous liquid. And in your head you have lots of non-homogeneous, several non-homogeneous tissues. So you are not mimicking, even for the adult. And for the children, it's known that children's heads are smaller, then you have more absorption in the head. Children dielectric parameters are higher than the adults, then you have more concentration of energy. The dielectric constant is higher in the children than in the adults. You have more concentration of energy, and the conductivity in their brain are also higher than in the adults. So you have at least three factors: dimension, dielectric constant, and conductivity, all together resulting in higher SAR. SAR is only a thermal result. So even considering only thermal effect to obtain the SAR, you are doing a wrong measurement. You are using an homogeneous liquid designed for the adults. Wrong. Okay? Second, you are doing the compliance test in the head of designed for an adult, and that cell phone can be bought by children. And sometimes if you go in the FCC site, you put the ID for your phone and you will have the SAR in the FCC site. And that SAR has been measured for an adult. And the children, they buy the same phone, and their mother, their father do not know that the compliance test has been done for an adult. And sometimes the SAR they have are 1.2, 1.3, and the limit in this country is 1.6. So if you add the three effects I was mentioning to you, you can obtain results 60% higher, 80% higher, or 100% higher. That has been discussed in this conference. So if you take a result with, say, 1.3 watts per kilogram, and if you put, say, 80% or 100% higher, you would end up with a cell phone that would not be in compliance with the 1.6 SAR limit. So they know that. People from FCC, they know that they are doing the wrong measurements. They are doing the wrong measurements. They should not use an homogeneous liquid. Brain is not homogeneous, first. Second, they are measuring in the head of an adult with 105 or 8 kilos.
So that's a large male.
Large male, yes. So when the Food and Administration, the FDA, is looking for a pill, for example, for adults and for the children, normally if you take 10 grams for an adult, you will have, say, for the same pill, 5 grams to the children. The same should be with the cell phone. And that's not only in this country. Every country makes the compliance tests with heads of adults. Every country. So, you know, it's a big problem.
So, any final advice that you would give a concerned cell phone user?
Yes, using headphones and putting the cell phone away from your body, I think it's a nice suggestion. Also, for the industry, if they were serious and responsible, just use technology available to reduce the exposure to the users, such as planar antennas, directional antennas. And also, all the other wireless systems, try to avoid them and use cables, optical fibers, whenever it's possible. And the base stations being placed far away from more dense populated regions, such as where people live or work. Of course, school, hospitals, at least 1 or 2 kilometers away. And as the technology, the present technology is very good, I'm sure systems will operate all right. I am in favor of the precautionary principle, and I do agree with the results shown in the bioinitiative report and the levels suggested in that report. And we have as an outcome of the conference in Porto Alegre last May, we sent a letter to the President of Brazil, and this letter was just saying something similar, which I have been telling you now. And also, tomorrow, a resolution called the Porto Alegre Resolution will be released for the print, for the media. And this resolution has been signed by international scientists and Brazilian people working on this subject. And this resolution is being released this week, and the aim of it is to try to resume what has been discussed and suggested in that conference in Porto Alegre last May. And it recommends the use of the precautionary principle for wireless technology, and reducing the levels of the exposure for the population, especially the children, and aiming to reduce the risks for their health.
And so the best possible outcome as a result of this would be it's an adoption by other cities? Or?
Yeah, it's recommending, we make an urgent call to all nations to convene a panel of experts selected from candidates recommended by civil society groups, not only those preferred by the industry, to discuss precautionary technology, laws, and advice in order to develop policies that reconcile public health concerns with further development of wireless communication technology, such as mobile phones, as well as electric power transmission and distribution systems.